These are the examples for Algebra 2B, Credit 2, Lesson 15.2. Lesson 15.2, we're going to be talking about the graphs of logarithmic functions. We're going to start with problems 1 and 2, which are writing an equation from given the graph of a logarithmic function. So we're going to be told here that the parent function, f of x equals log base 3 of x, and which function is graphed on the coordinate plane given. So we're going to write our answer in this form in the end. G of x is, we're going to need to solve for a, for, b we're given, the base, and then for h, and then for k. All right, so let's start with, let's start by making that a little bit better. All right, so the base is given, so the base is 3. Now here's our graph of our logarithmic function, and we're given 2 reference points with it. But for h comes from the asymptote. And so it looks like the asymptote is going through 1, 2, 3, 4, -5 on the x-axis. So h would be -5. Next is k. K is the y-coordinate from the first reference point. Now, which one's the first reference point? Recall that the first reference point is the one that's closer to the asymptote. So this point is closer to the asymptote than this one. So our first reference point is here, and then the y-coordinate is -1. So k is -1. Now we have this little equation, just like we saw with exponential, writing an exponential function from a graph. A plus k equals y. K is -1, so it's a -1 equals y. So now what's the y-coordinate on this one? Well, you might remember with exponential, we didn't use the second reference point, but with logarithmic functions, we will. The y is the y-coordinate from this second reference point, and so y is 3. All right, we have a -1 equals 3. We're focused on the left because that's where a is. We got to get rid of that -1, so we're going to add 1 to both sides. The 1's cancel out, and 3 plus 1 is 4, and so a is 4. And so now we have all of our information, and we're ready to write our function. So let's go ahead and do that. We got g of x. We know that a is 4. Our base was given as part of the parent function, which is 3. Let's make that look nicer. And then x minus h. H is a -5, so x minus a -5 plus k, and actually k is -1, and so -1. Now, the only thing we can simplify here and clean up a little bit is this minus. Subtracting a negative does become a positive, and so through the magic of a dry erase pen, we will just erase that. That minus becomes a plus, and our final answer, g of x equals 4 times the base 3 log of x plus 5 minus 1. All right, so that's our example for number 1. Number 2 is very similar. So let's go ahead and again, pause. There are a few things going on here. So make sure you pause, rewind the video, and make sure you have the best understanding possible. All right, so let's go ahead and erase as little as we can here so that we can not have to write as much up here. This is our example for number 2. Our parent function is going to be a base 2 logarithm. And this is our example for number 2. And we do have to change the graph. So let's go ahead and do that. All right, so we've got our logarithm. Here our graph. Asymptote going through -4. I guess we're giving away some of the answers over there. If you remember what that affects over there, which of those letters, that's going to help you out already. Let's see. We have -3 and 1 would be right here. And we also have another reference point at -2 and 0. So let's maybe write that here. And there's our asymptote, and we draw that in. Now, this time the graph is kind of flipped the opposite way. So one of the things say, well, what's the big deal about that? Well, good question. So that tells us, since this is reflected vertically over the x-axis, that we're going to expect A to be negative. Now, we don't know what negative value it will be yet, but we do expect it to be negative. All right, so let's start filling in our information here. From the parent function, we know that B is 2, our base is 2. Remember, H is the asymptote, where the asymptote passes through the x-axis. So it's 1, 2, 3, 4, negative 4. So it's passing through the x-axis at negative 4. So H is negative 4. Now remember, you know what? I just realized I don't like, because that might mislead us to what is the first and what second reference point. So let's put that over there. All right, so now we need K. K, remember, is the y coordinate from the first reference point. The first reference point is one that's closer to the asymptote, so it's this one here, and so K is negative 1. Now we have our little equation to set up to solve for A. We have A minus 1, because K is negative 1, equals Y, which is our y coordinate from our second reference point. And y is, let's see, we did, you know what? This is supposed to be positive 1. There we go. I knew something wasn't right there. Okay, there we go. Okay, so that was negative 3 and 1. I think we said it. We just wrote that wrong there. So K is, which makes K positive 1. Oh, there we go. Let's fix all that. All right. So to review, again, base is 2. H is negative 4 from our asymptote. K is positive 1, the y coordinate from that first reference point. And now solving for A plus K. K is, again, 1, and then y is that y coordinate from the second reference point, which is 0. All right, so now we're going to solve for A. We have a plus 1. The opposite of adding 1 is to subtract 1. The 1's cancel out, and 0 minus 1 is negative 1. All right, so now we have our values for B, H, K, and A. Let's go ahead and substitute those in and write our function. So we have g of x equals A, which is negative 1 times log base 2 of x minus a negative 4, and then plus K, which is that positive 1. All right, so a couple of things we can clean up here. Remember, when the coefficient is a 1, we don't need to write that, so we could just say negative. We do need the negative, but not the 1. So we could just say negative log base 2. And once again, we have this minus minus here. So remember, subtracting a negative is the same as addition. So we have x minus a negative 4 becomes x plus 4 plus 1. So our final answer there, g of x equals negative log base 2 of x plus 4 plus 1. All right, so that is it for the examples for problems 1 and 2. So let's go ahead and let's see, I think we are done with the graph. Yes. So let's go ahead and erase this. And again, just as a reminder, pause, rewind the videos, because there are a few steps to these problems. We want you guys to do the best that you can, so definitely take the time to do that. All right, so going over to page 25 now, we're going to be talking about the transformations. So we've talked about transformations with so many different types of functions: quadratic, cubic, exponential, and I'm probably forgetting a couple others. But now we're going to talk about transformations with logarithmic functions. Oh, square root function was one of them, I believe. So the good news is the rules are the same as far as what A does, what H does, what K does. We'll remind you of them. But let's go ahead and take a look at an example. This one's going to be for problem number 3. All right, so let's go ahead and maybe put our rules over here. Let's do that. So we have f of x equals a log base b of x minus h plus k. All right, so as always, remember the a does two things. First of all, if it's negative, it's a reflection over the x-axis. So we're going to try and write this quickly. And again, if you want to hear the explanation again, of course, pause the video or rewind it. Now, the other thing that A does, it can either vertically compress or stretch the graph. Remember, if A, the absolute value of A, we should say, let's put it like this, is between 0 and 1, that's a vertical compression. And then if the absolute value of A is greater than 1, that's a vertical stretch. And remember, when we say absolute value, we're just talking about the numerical part, because if A is negative, we've already dealt with that. That's the reflection over the x-axis. So A, the number that's there, whether it's positive or negative, it's between 0 and 1, it's a vertical compression. More than 1, it's a stretch. All right, now with H, remember H, it's minus H in the general form. So it's the one that's counterintuitive. Plus H is going to move us to the left. Minus H will move us to the right. Translate as left or right. Finally, K. K is the nice one. So we end on a good note here with the descriptions. K moves us up or down because it's this part that's outside the parentheses. Plus K moves us up. And then minus K moves us down. Yeah, let's make that look a little bit nicer. All right, so using that information, let's talk about transformations on 3 and 4. So we have the base, that's not going to come into play with our transformations that we're discussing here. So let's take a look. We have g of x equals negative log, whoops. Yes, that's right. Make sure we do the right one. Log base 7 of x plus 3. All right, so let's go ahead and take a look at that, the transformations. And let's write that a little bit neater. All right, now looking up here, and actually we probably should put the parent function, which is log base 7 of x. So in addition to the log base 7 of x, what else do I see down here? Well, I see a negative, and I see this plus 3 here. So it looks like there's 2 transformations that would be on this graph that we would see if we actually graphed it. So remember, if A is negative, that's a reflection over the x-axis. Over the x-axis. And then the other thing here is 3. Now, is this 3, is that H or is that K? Well, if it's in the parentheses, it's H, and it is in the parentheses. So let's see, plus a number, plus moves us to the left. And so that's going to be a translation of 3 units to the left. So translate 3 units to the left. And that's it. So this graph, the parent function would be reflected over the x-axis and then translated 3 units to the left. And that's it. That's all you got to do for number 3. So just the 2 transformations. All right, so let's take a look at an example for problem number 4. For problem number 4, let's get all this up here, get this erased. All right. It'd be nice if we had several dry erase boards. We could just have it all set up and just move one to another. But as it is, we have one good one, so we're good. All right, so let's take a look at this one here. Our example is this. So our parent function is base 5 logarithm. And we have g of x, if I can find it here. There we go. 1/4 log base 5 of x. And this is going to be minus 8. All right. So looking up here, in addition to, all right, good. Just double checking there. All right. So in addition to what we have here, what other things do you see written down here? Well, in addition to the log base 5 of x, I see a 1/4, and I see a minus 8, and I notice that it's outside the parentheses. All right, so looks like we have once again, 2 transformations. So now this time, A is 1/4. It's not negative, so there's no reflection over the x-axis, but it's 1/4. So is 1/4 between 0 and 1, or is it more than 1? Well, it's between 0 and 1, so that would be a vertical compression. And again, if it had been more than 1, that would be a vertical stretch. So a vertical compression by a factor of, well, 1/4, whatever A is. And if even if it had been negative, as we saw in the last one, it would just be whatever that number is, not the negative sign. All right, now the other thing we see is the -8. The -8 is outside parentheses, so that's not H, but it's K. And so minus, it moves us down. So that would be a translation. So whenever we're talking about left, right, up, or down, that's a translation. So translation of, well, let's say 8 units down. And that's it. Those are the 2 transformations there. Okay, and of course, if that had been +8, that would have moved this up 8 units. All right, so that's it for example for number 4. And so that is all we need this for. And now we're going to move on to the last part of this lesson, and that's determining the domain and range from the function. Domain, remember, refers to the x values, range referring to the y values. So let's go ahead and take a look at an example for number 5. Both 5 and 6 are very similar, but I think we'll still do 2 examples. All right, so we have y equals log of -x plus 7 plus 1. So as it turns out, you cannot take a logarithm of a negative number. So for the domain, we have to find the values of x. So whatever we're taking the log of, it has to be more than 0. So let's go ahead and set this up. This is our domain. So we would say -x plus 7 is greater than 0. So whatever the logarithm that is, that number, that expression has to be greater than 0. All right, so let's go ahead and solve for x here. We're focused on the left side. We have a +7, so we subtract 7. We have -x, and it is greater than 0 minus 7, which is -7. Now, we're not done yet because we got to get rid of that negative. So remember, if there's no number there, we know there's a 1. X is being multiplied by -1, so we divide by -1. The negative 1's cancel, and -7 divided by -1 is a positive 7. Remember, a negative divided by a negative is a positive. Now, notice I didn't write the inequality. Something we haven't seen in a while is that, remember, when you multiply or divide by a negative and you're working with inequality symbols, that causes us to flip the inequality around. And there's a reason why, just real quick. Let's say we had the statement 10 is greater than 2, which is true, right? But if we multiply both of these by -3, we get -30 is greater than -6. Well, that's not true. A number that's closer to 0 is going to be larger. And so that shows that when we multiply by a negative with an inequality or divide, that causes the inequality sign to flip. In other words, the side that's bigger is going to switch. All right, so our domain here, and let's see, is there any special way you want us to write it? Well, actually, just they give you the answers. You just have to identify which one's the domain, which one's the range. So that would be the domain here. Now, the range, when you have a logarithmic function, as we saw a minute ago on the graph, so the graph, we have that wherever it might be, the vertical asymptote, but the graph, even though it looks like it flattens out, it does continue upward forever and obviously downward forever. So with a logarithmic function, it goes up forever, down forever. So the range on a logarithmic function is always going to be all real numbers, or we're using interval notation. All right, so we'll rewrite that as interval notation. So all real numbers would be from -infinity to +infinity. And then our domain, x is less than 7. Let's put it over here to remind us of what it is. So x is less than 7 means 7 is the high point, and then it goes into -infinity on the small side. So writing x is less than 7, with interval notation would be negative infinity up to 7, not including 7. If we'd include, remember, this goes back to credit 1. If we'd included 7, we'd use a bracket there. All right, so that is the domain. That's the range. So it kind of makes it a little bit easier because you know the range with a logarithmic function is always going to be all real numbers, or in interval notation, negative infinity to positive infinity. So that is the domain and range. All right, so let's take a look at an example for number 6. And here we go. So our last one, and we have this. We have example for number 6, and we have log of negative x minus 8 minus 3. All right, so we'll start with the domain. Once again, we're going to put the answers in interval notation. So starting with the domain, and again, we already know there's not going to be any work for the range because we know the range is going to be negative infinity to positive infinity. All right, so we take the expression that we're taking the logarithm of, and we say, well, that has to be positive, so greater than 0. And then once again, we'll solve for x. We have a minus 8, so we add 8 to both sides. The 8's cancel. We bring down that negative x, and 0 plus 8 is 8. But once again, we're not done because we have this negative there, or negative 1. X is being multiplied by negative 1, so we divide by negative 1 to both sides. The negative 1's cancel out. Remember, we divided by a negative. So again, you multiply or divide an inequality by a negative. That inequality symbol flips around. 8 divided by 1 is 8. Positive divided by a negative is a negative. So x is less than negative 8. So writing that as interval notation, we would have negative 8 on the high end on the right, and it's everything less than negative 8 onto forever, so into negative infinity. So that would be our domain. Our range, remember we said for a logarithmic function, it's always all real numbers. So negative infinity up to positive infinity. And you would just write the correct word, domain or range, by the correct symbol. So if you had both these symbols, so next to this one, you would write domain. Next to this one, you would write range. All right, so that is it for the examples for lesson 15.2. Kind of erased the 2 there, didn't we? So that is it. So again, pause, rewind the videos as needed, and study the work. And tell you, if you work hard at it, work diligently, you're going to do great with the work. So again, good luck with the work. And until the next video, take care and God bless.